Hello. The goal of our spaceship is to develop and study different forms of artificial intelligence. As we build more and more intelligent robots, we would be able to also study the interaction between the two different societies, the one of humans and the one of robots. This way, the horizon of artificial intelligence will be forever broadened, and with it, the exploration of space will begin a new chapter. The spaceship would also be able to sustain touristic activities and exploration due to its modular structure. Now the name. Sileo comes from Latin. It means silent. This is a reference to the loneliness our human crew is going to experience in space. Leaving your home planet, knowing that you'll live the rest of your life on a spaceship thousands of miles away, is certainly not an easy feeling to get over. The other word, Ibis, comes from Latin too. It means owl. This makes a reference to the intelligence, the wisdom, and the future connection between artificial intelligences and human beings.
Location. Considering the spacecraft's aspects and purpose, we chose to place Sileo Ibis around Mars on an orbit which is 100 kilometers above its atmosphere. The location provides enough solar light to produce energy, the radiations are relatively low, so the spacecraft is not exposed at great danger. Moreover, this location provides useful materials such as water, gases, and minerals. We planned missions for resource-bringing spacecrafts. As you can see, there is their form while being stationary and there while traveling. They have aerodynamic form and they are equipped with instruments such as excavation arm, volatile and gases collectors, sensors, and more.
We consider that the structural design of the spacecraft is one of the most important aspects of our project. The spacecraft that we designed has a modular structure composed by simple shapes that form a more complex design. The final shape was obtained by improving and evolving the original idea up to the point where we couldn't see any other possibilities of improvement. In this way, we obtained a number of important attributes: an optimal amount of available space at different artificial gravity values, an efficient division of space inside the modules, an even repartition of stress among the structural components, an easy to navigate through the structure, and so on. The materials chosen to be used in the construction of the spacecraft are both classical and new. Carbon nanotubes are a common example needed in order to construct the space elevator. Another example are boron nitride nanotubes, a strong, lightweight material that has the property to block most of the harmful radiation. So, obviously, it will be used for radiation shielding. A problem we encounter when searching for the perfect materials is that the quantity of the material that we need may not be available. This is why all of the new developed materials will be used alongside with the more common ones, aluminum and steel.
Now, I'm sure you're familiar with movies like Terminator or 2001: A Space Odyssey. The concept is simple. A super intelligent computer decides that humans are useless or damaging and starts killing them. Of course, those are works of fiction, but they do raise a very important question. Would artificial intelligence possess a potential threat towards humankind? Our project aims to answer this exact question. We are uncertain when and if human-like artificial intelligence would be discovered, but consider the progress we've made over the last decades. 43 years ago, we had just created the first personal computer, and now we have computers programs capable of walking like humans, speaking like humans, learning like humans, and even outsmarting humans in games that take years to master. Some of them even showing a little level of self-awareness. I think it's safe to assume that the dawn of super-intelligent computers is pretty close. Now, to quote Eliezer Yudkowsky, by far the greatest danger of artificial intelligence is that people conclude too early before understanding it. So, before opening the box of Pandora and beginning to shape our future, maybe we should firstly test this new technology in a controlled environment. The most secluded place in which we could test a symbiotic society between humans and artificial intelligences would be in space. In this society, we would be able to study and develop the way artificial intelligences interact with humans. AIs will be able to learn from us, and we will be able to learn from them. Once we make sure that the AI business is completely safe, we could bring the robots back to Earth and forever change the world as we know it.
We are collecting water from more than only one location. Of course, Mars is our main supply, but we also bring water from Europa, Jupiter's moon. After being brought to the spacecraft, the water goes through multiple systems, and the purification yield is up to 99%. Our daily need of water is 1,250,000 liters. If any problem occurs in the water system, the industry is able to produce the water artificially.
In the living areas, the composition of air is very similar to the one on Earth. The oxygen is produced using the electrolysis of water and solid oxide electrolysis. Through the last process, the oxygen is produced by decomposing the carbon dioxide from the Mars atmosphere. The other gases are also extracted from Mars.
Energy. After analyzing several methods of obtaining energy, we decided that the best solution would be solar energy. We will be using mirrors made of tinfoil and reinforced with graphene to deflect the optimal amount of sunlight towards the solar panels located on the base of the cones. Omnidirectional gas propellers will be attached to the frame of the mirror in order to move them and to orientate them in the best position. Additionally, we will transform mechanical energy from the gym equipment into electrical energy.
Recycling. We divided this section into three. The first one, material waste, which has its own 10 subcategories, as you can see there in the picture. Then here it comes heat waste and wastewater. All of them are recycled industrially, and they work through mechanized systems.
Unlike the intelligent robots, the human crew of the spaceship is going to need a constant supply of food. As natural soil is quite heavy to be carried in space and quite dangerous to keep aboard due to some pathogenic factors, we are going to use a synthetic material to replace it. The quality of the crops will certainly not be the same as the one here on Earth, but it is proved that this synthetic replacement is more efficient and fertile. Thank you for watching.